like we've been doing the whole time, we are going to add another layer, another level of difficulty to solving multi-step equations. You know how to solve equations like x plus 3 equals 5. You know what to do there. You subtract 3 from both sides. X equals 2. You know how to solve 2x plus 6 over 4 equals 5. You multiply here and you get 2x plus 6 equals 20. Subtract 6 from both sides. 2x equals 14. Divide by 2. X equals 7. So this was day 1, day 2, day 3, and 4. Now we're going to do it when you have variables on both sides. Now when you have variables on both sides, you can solve it, believe it or not, 4 different ways. I'm going to show you one way, all right? Let's do the t. Well, actually, right now, you only have variables on one side. Sorry about that. So, you learned in Unit 1 to combine like terms. So look at this equation in A. See how we have a 2x and a 3x? We put them together, they become 5x. And we still have plus 4 equals 19. So we combined our like terms. We're following the steps. We've done order of operations way back in Unit 1, and there's always a process. Well, for doing these algebra problems, first you get rid of the parentheses, which means you apply the distributive property. Well, there aren't any parentheses here, so we don't have to worry about that. We can kind of check that one off. Then you combine like terms. Put all your x's together on one side of the equal sign. That doesn't mean just mix and move them all around. It means any x's on the left side get put together in one. Any x's on the right side get put together in one, like we did here. I had x's on the left side, I combine them into one. So now they're 5x plus 4. Then you solve it the way you have been. 5x equals 15. I'll put it up here so we can finish it. Divide by 5. And x equals 3. Let's do another one. All right, draw the T. Especially now, the T is very helpful because it reminds you to not just mix and match things. Let's look over here. We have a 3x and we have a negative 9x. We're going to combine those. Now, this was a Unit 1 test. 3x minus 9x is negative 6x. And then you just bring down the rest of the equation. We haven't done anything with it. We just bring the rest of it down. Now, move your 7. And you have negative 6x equals 30. We still want 1x. We want to get the value of 1x, so divide both sides by negative 6. You divide by whatever is in front of the variable. So now you have x equals negative 5. You may want to study this one. All right, let's try another one. Well, actually, this is where you're going to stop the video. I want you to do it on paper, and then I want you to come back and see if your steps matched mine and if we got the same answer. Okay, drawing my T, adding my two variables, negative 5x plus 2x is negative 3x, and I still have minus 8 equals 13. I just bring the rest of the stuff, carry it along, add 8 to both sides, and I have negative 3x equals 21. Divide both sides by whatever is in front of the variable, which is a negative 3. X equals negative 7. Those are multi-steps because they took more than 2 steps. All right, let's go to the next page. Now, we have variables on both sides of the equation. So, you're going to draw your T. T is the Great Wall. You really need the wall, trust me. You decide if you want to move your variables to the left or to the right. You decide if you want to start moving your integers to the left or to the right. It is your choice. I am going to move my variables. I'm going to do my problem a different way each time. I want you to see it. The first time, I'm going to move my variable over here. First I looked. There were no parentheses for me to deal with, and there were no other x's on the right side or the left side. So now I'm moving my variable. See, that cancels out, and I have 0x on that side. I have 5x plus 4 equals 19. I bring the 4 down, there's the equal sign, and I just bring the 19 down. Now I'm going to subtract 4 from both sides because that's how I move it. I end up with 5x equals 15. Divide both sides by 5. X equals 3. So on that one, I went moved variable to the left. I'm going to do the next one a different way. Okay, I'm still going to draw my T. This time, I'm going to move my integer first, because there is no rule that says you have to move your variable first. I'm moving my integers first. I'm going to move the negative 4. I'm going to add 4 to both sides. There were no parentheses to do, and there were no x's on one side or integers, multiple integers on one side. Everything's all set up nicely. 6x equals negative 2x minus 16. Now I still need to get my variables on one side of the equation. So now I'm going to move my negative 2x. You would think, okay, I'm going to divide. You're not dividing. You're subtracting the entire unit. And that's might get confusing. This whole thing is 1 unit. See, up here, whole thing is 1 unit. So I'm just moving the whole unit. Plus 2x plus 2x. That gives me 4x equals negative 16. Let's put it over here. Divide both sides by 4. X equals negative 4. Here, moved integer to the right. That was my first step. Okay? I want to show you, I want you to understand that you do not have to start moving your x's. If you want to do that every time, go for it. If you want to move your integers every time, go for it. There are different ways to do this, and I want you to understand that. All right, now, another one, you're going to try it. I want you to do it, and then come back and check. All right, drawing my T. I do not have parentheses I need to do. I do not have more than one x or integer on each side of the equation, so I can just go ahead and start moving. Okay, this time I'm going to move variable to the right, changing it up. All right, remember, it's 1 unit. I do not split up my negative 5 and my x. That is 1 unit. So I'm going to add 5x to both sides. And I do want to line it up, because if I line it up nice and neat, it helps me remember what I'm doing. 5x. That's 0. I have negative 8 equals 9x minus 26. And now I have to move the integer. Remember, x is on one side, integer's on the other. I'm going to add 26 to both sides. 18 equals 9x. Put it up here so I can finish my equation. Divide both sides by 9 because that's what's in front of the x. 2 equals x. Do not rearrange things. Now, speaking of rearranging, okay guys, if your variable is on the left and ends up being on the left, fine, you have x equals 3. If your variable ends up being on the right, you have 2 equals x. That's fine. You do not have to have x equals, okay? It doesn't have to be like that. It can be 2 equals x instead of x equals 2. The math is still the same. The math is the important thing. So as long as we end up with the same product, we can do it slightly different ways. And that takes care of day 5.